Hello everyone. So friends, in our previous lecture we discussed about the two main characteristics of a dynamic programming problem, which was optimal substructure property and overlapping subproblems property. So friends, till now we saw that how we can solve a problem using recursion. So in this lecture and in upcoming lecture we'll see that how we can solve a problem using dynamic programming. So friends, there are two approaches to solve a dynamic programming problem. The first approach is bottom-up approach. So what do we mean by it? In bottom-up approach, we try to solve smaller subproblems first, use their solution to build on and arrive at the solution to bigger subproblems. So which simply means, so let's say if you want to solve a complex problem, so instead of solving the complex problem at once, what we do is we start with the smaller subproblems. We try to solve those subproblems. We use those subproblem solution to arrive at a solution to the bigger subproblems. And this way we try to solve the bigger subproblems and finally reach to the solution of our main problem. So the bottom-up approach is also called the tabulation method, because in this approach when we solve the smaller subproblems, we usually store the result of those smaller subproblems into a table, and when those smaller subproblems are encountered again, then we simply use the values from the table to arrive the solutions to the bigger subproblems, and this way solving the chain of subproblems we reach to the solution of the main problem. Therefore, the solution is built in a tabular form by using the solutions of smaller subproblems iteratively and generating solutions to bigger subproblems. So friends, in our previous lecture we saw that when we used recursion and when we solved the nth Fibonacci number problem, we saw that it was less efficient code because we were recalculating the subproblems again and again. So instead of recalculating the subproblems again and again, what we do is we store the results of those subproblems in a table, and when those subproblems are encountered again, we simply use the values of those smaller subproblems from the table itself without going to solve those subproblems again and again. So friends, now let's look at the demonstration of bottom-up approach, that how we can use the tabulation method to memorize the solutions of the subproblems and reuse them later when those subproblems are encountered again. So here you can see that in this example we are simply calculating the nth Fibonacci number, and this time instead of using recursion, we are using the bottom-up approach, which is nothing but solving it via one of the methods of dynamic programming. So let's say we want to calculate the fifth Fibonacci number. So here, when we call this function fib, the value of n will be 5. So in the first step what we do is we simply create a table which is nothing but an array to store the result of the smaller subproblems. So when we want to use the result of those subproblems again, we can simply refer this table, pick up that value and simply reuse. So friends, here we will simply create a table of length n plus 1. We will see why we are taking the length as n plus 1. So it would look something like this, that there will be an array by name table having 6 elements from 0 to 5, and we are using n plus 1 because we know that array starts from 0, and if you want to calculate the fifth Fibonacci number, the value of fifth Fibonacci number will be stored at the fifth index of the array. So therefore we are using n plus 1. Moving ahead. So friends, as we know that Fibonacci series starts with 0 and 1. So here you can see we are simply assigning the value as 0 and 1 to the 0th index and the first index. So we are assigning 0 to the 0th index, and then we are assigning 1 to the first index. Moving ahead. So friends, here you can see that we want to calculate the fifth Fibonacci number, which is this, but we are starting from the bottom by using these base cases. Therefore, this approach is also called as bottom-up approach, because we build our solution by traversing from the bottom and we move up and finally we reach to our solution. So friends, here you can see that we have calculated the value at 0th index and at the first index. So now what we do is, we provide a for loop. We start from the second index, and this for loop will go till the value of I is less than equal to 5. So here you can see I becomes 2, and as I is equal to 2, here we can see that I is less than equal to 5. Therefore the condition in for loop comes out to be true and the for loop executes. Also friends, we know that how we can calculate the Fibonacci number. We simply do the sum of its two preceding numbers. So here what we are simply doing, we have already stored the result of 0th index and the first index, and when we want to calculate the second Fibonacci number, we simply do the addition of the first preceding number, which is I minus 1, and the second preceding number, which is I minus 2. So this is nothing but we are doing the sum of its two preceding numbers, because in this table we are actually storing the Fibonacci series. And when we want to calculate the second Fibonacci number, we simply do the addition of its two preceding numbers, which is 0 and 1. So here you can see the value stored at table I minus 1, which is 2 minus 1 index, has value 1, and the value stored at table I minus 2, which is 2 minus 2, has the value 0. So we'll simply add 1 plus 0 and store the value 1 at the second index here. So these are the two preceding numbers which we will add and store at this position. So now the value at second index becomes 1. Moving ahead. Now we'll increment I. So I becomes 3. And now we want to calculate the value at the third index. So we'll simply do the sum of its two preceding numbers with I minus 1 and I minus 2. So I minus 1 gives the second index value and I minus 2 gives the first index value. We'll do its sum, which is 2, and we'll store 2 at the third index. So value 2 is nothing but the third Fibonacci number. Moving ahead. Now when we increment I by 1, I becomes 4. And now we want to calculate the value of the fourth Fibonacci number, which is stored at fourth index. And this value can be obtained by doing the sum of its two preceding numbers, which is at index 2 and 3, which can be obtained by taking the value of the table I minus 1 plus I minus 2. So I minus 1 gives the value at third index. I minus 2 gives the value at 4 minus 2, which is the second index. So we'll do its sum. 1 plus 2 becomes 3. We store 3 at the fourth index. Moving ahead. Now we'll increment I by 1. So I becomes 5. and then we'll simply calculate the fifth Fibonacci number by doing the sum of its two preceding numbers, which is nothing but I minus 1, which is 5 minus 1 equal to 4, the fourth index, and I minus 2, which is 5 minus 2, which is 3, and that is nothing but value stored at third index. So we'll do the sum of these two values, which is 2 plus 3 equal to 5, and we'll store the 5 at the fifth index. And now we'll increment I again, so I becomes 6, but here you can see that 6 is not less than equal to 5. Therefore the condition in for loop comes out to be false and for loop terminates. So friends, we simply return the value stored at fifth index, which is nothing but our fifth Fibonacci number, which is 5. So friends, here you can see that in our previous lecture we used recursion to solve the nth Fibonacci number problem, and we saw the solution was very less efficient because we recalculated the values of the sub problems again and again. So here what we did, we simply created a table to store the results of the sub problems, and when we wanted to use the values of the sub problems again, we simply referred this table, use those solution and build up upon the solution to the main problem. So here we started from the bottom, which is from the 0th index and the first index, and as we knew that the first two number of Fibonacci series are 0 and 1, we simply used those two values to come up with the second Fibonacci number. Then we used the first Fibonacci number and the second Fibonacci number, we did its sum, we got the value of the third Fibonacci number, and similarly we got the value of fifth Fibonacci number. So friends, here you can see that using this tabulation method we are storing the results of the sub problems, and we are not recalculating the values of those sub problems. We are simply referring to this array, we are taking out the values, and we are simply using to build up upon the solution to the main problem. So this is a bottom-up approach to solve the problem of calculating the nth Fibonacci numbers. So friends, now let's go to Eclipse and see the demonstration of this code. I hope you like this video. Thanks, have a nice day.